talk about how to use the cross section to do the to calculate the volume by using the definite integral. So it's a very typical example for by using definite integral. As I mentioned, that the applications of definite integral we just include two parts. The first one is actually three parts. The first one is try to use the definite integral to calculate the volume, 算体积. Okay. The second one is to calculate the surface, 表面积. Okay. And the third one is how to calculate the arc length, 弧长. So in this chapter, we will include these three parts mainly. And the very basic concept is just using the cross-section idea. The so-called cross-section idea is if I give you a solid and ask you to calculate the volume like this, then you can just use a cutting plane to cutting the volume, the solid at any point, and then summarize all of the small volume for each small pieces. Then you can just sum them up, then finally get the whole value for this solid. So the idea is simple. So that means, first of all, we need to try to get the typical cross-section and try to formalize it as its area A of X. Then we try to just using the A of X, that means the area of the cross-section times a small width. Then we can get the small volume for this part. Then finally sum them together. So I also give you the example. Maybe it's hard for you to image that, but if you just carefully think about the cross section, it will be a rectangle. So the first thing for you is you need to try to get the typical area for each rectangle, because as you cut it vertically, you can see each cutting can cause a rectangle region for each small portion. Then finally you just sum them together. So this is a typical example, and we also learn about the first idea about the study of revolution by using the disk method. So this method just follow this idea. Then you can just try to get the typical area for each piece. Then since in this case, for example, we have a curve here, we try to use this region as a basis, then try to rotate this plane region about the x-axis. Then you can see the volume will be like this one. So you can also see the cross-section here is a typical circle or typical disk. So that's why we just call it disk method. Then for each part, you always can get a disk. For example, here is almost a point, right? But as increase, you can see the circle will keep growing, right? And then finally, you just sum them together by using the previous idea, then you can get the whole volume. So this is a typical example that the formula is just like this one. Integral from the start n to the n, then pi r squared. Because for each part, we can just use the function value as a radius. Then using this as a radius, then you can get the area for this disk. Then times the small portion dx. Then finally sum them together. So you can see this here is just about a formula of calculating the area of the circle, right? And or we can say this just calculating the area of the disk. Then finally sum them together. So I also illustrate this example for you that you should remember if the rotation axis, for example, this one is just following the rotation axis as x-axis. However, for the same curve, if I just ask you to rotate it about the y-axis, the result will become different. Because if you just follow this one, rotated about the x-axis, then the result will using this as its radius. However, if you just use the y-axis as the rotation axis, you can see here will be the radius, right? So then, following the same idea, but this time it will be dy, and of course, the radius or the length will be viewed with respect to y. Then you can also get the value, and the shape will just like this one. Okay, so next time I will show you how to using the idea to calculate the volume of a sphere, even though you already memorized the formula for the volume of sphere, but right now we already have the capability to calculate the volume size for a sphere. Okay, so today we can continue for this part. That okay, we still start by an example that rotation about a vertical axis. Okay, the question just looks like this. Please just find the volume of the solid, which is generated by rotating the region between s is equal to y squared plus 1 and s is equal to 3 about the line s is equal to 3. So when you just are given a question like this, the first thing for you is just try to get the region first. So the region will follow this rule between blah 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 and blah blah blah. And finally, the question will also list what is the rotation axis. So for you, the first step, please just try to draw it. If this axis, this is y-axis, then start to draw it. S is equal to y squared plus 1. It's a parabola. But the parabola is just look like this one. So this is S is equal to y squared plus 1. Right? This is parabola. And this is a vertical line. S is equal to 3. So this is S is equal to 3. So with these two curves, you can enclose a region. This one, right? So this step, just finish the drawing the region, right? If I give this and also give this and try to get the plane region, right? If you have the plane region, then try to find its rotation axis. So the rotation axis is a line x is equal to 3. So luckily, it is here. So this is also its rotation axis. And then, what is the volume by rotating this plane region about this axis, right? So this is a vertical axis, right? Okay, so with this is the first step. You are trying to just drawing it out, by drawing this. So the first step we already finished. The second step is, okay, if we just rotate it like this, we need to find the typical cross section. So for example, if here at some certain y, at some y is blah blah blah, right? So how much value it can contribute? So we can just use this as its radius, right? Then try to use this to rotate it. Then you can try to rotate it, and then actually you will get this one, right? Something like that. So the first thing for us is we need to figure out what is the R. What is the R? So R of Y means the radius should be, in this case, you can see the yellow one is larger than this parabola. So it should be 3, then minus y squared plus 1. Right? Because at least each y, you should calculate radius. So radius R here will be depending on y. Where is y? For example, if y is here, the radius is just like this one. But if y is here, the length is just like this one, right? Y is here will be the green line to the yellow line, right? So anyway, if you just subtract by using this axis with this one, x is equal to y squared plus 1, then you can get the length, right? So this is the typical radius for each cross section. Okay, so the result will be 2 minus y squared. The third one is we try to get the disk size, right? So the disk size here will be also depends on y, right? Because y is here, we can get this disk, right? If y is here, if r is here, we can get this disk. If r is here, we can get a little bit larger disk, right? So a of y will depend on r of y. So it will be pi r of y squared. So that will be pi 2 minus y squared. So, okay, so maybe the third step should be the other one, not this one. Okay. The third step is we already know about the disk size, but we also need to know where is its start point and where is its end point, right? Right. So how can we just sub this? How can we get these 2 points? So how to get these two ones? We just use these 2 points must simultaneously satisfy y is equal to y squared plus 1, and also s is equal to 3. So based on this, we can get 3 is equal to y squared plus 1, so that y will be positive or negative square root of 2. So that means there are 2 points. One is negative 2 to positive, negative square root of 2 and positive square root of 2. So the answer is this point should be negative square root of 2. This point is positive square root of 2. So right now we already have all elements. We already have this size, and we also know the start point and end point. So then we can just put these factors together, then form the integral. So the next one will be, the volume will be integral from negative square root of 2 to positive square root of 2, then a of y, then dy, right? So it will be like this, I times 2 minus y square dy. So I also skip the calculation, but I believe you can do it by yourself. Then the result is just like this one. Okay, so let me just quickly review the whole processes for you. The first step, please try to draw the plane region by the curve. They just give you. So here we have two curves to form the region. So here will be the y is equal to y squared plus 1, and the second one is x is equal to 3. So you can with these two curves, you can just determine the closed region. And the second one is the second very important parameter is s is equal to 3. This is the rotation axis. So this time the rotation axis is exactly the same as the boundary line. So it's also s is equal to 3. So then we can have using this one. So and then try to get each the typical disk. If you want to get the size of the disk, the typical disk, the first thing you need to get is try to get the radius, right? So the radius r of y is equal to 3 minus y squared plus 1, and then you can have this. Then you can get this one for each disk. Then finally try to put the parameter together. But the third step is you need to measure the two ends. If you want to get the two ends, you can just you can just use these two curves and try to find the intersection point. That means these 2 points just simultaneously meet the requirement for these 2 curves. Then you can have this, right? So then try to put them together to form the integral. Then try to get it. Okay? So, okay, we still follow this example. Can we just image that if the rotation axis is not the same as the yellow one? For example, okay, let me just, for example, how about for example, if it's here, also here, right? As I draw, and here, this is yellow line, right? But the rotation axis is just from here to move here. And I also ask you, using this as the cross region and yellow the red line as the rotation axis. So I believe we can image that the volume for this case is different from this one, right? The only difference is the rotation axis is the same as the one of its boundary. But here, we just slightly move a little bit far away from the boundary. For example, if here is s is equal to 5, how will happen? Can you still follow this way? No, right? Because the shape is totally different, right? So if this one, what is the volume? Of course, you cannot follow this one, but you can follow the idea twice. Just think about it. You can use this one, the yellow one, the green one, to rotate, then subtract the volume for the yellow parts. Okay? You know what? You can just use this one to rotate. You can rotate it, but for this part, you can also rotate it, but you just subtract it. Right? Just like 手拉胚，有像手拉胚，手拉胚两只手两个 curve， 然后拉，中间就会有个中间的那个碗容器的那一部分出来 ，right? So this one is another method. This one we will call it solid of revolution type 2. The washer method. 洗衣机 Right? Can you just imagine if you have rotation region? By using this as a rotation axis, you can see, you can get the washer foam type of solid, right? Okay, so actually the typical washer method just apply the Dix method twice. For example, this is the outer one. If the outer one is this one, y is equal to big R of x. And there is also a inner one, y is equal to small r of x. Then using this here to here, s is equal to a to s equal to b. By using this per region and use this as its rotation axis, then you can get, how can you get the value? How can you get the value? So you can see actually it's not that hard. The v will be integral from a to b pi r big R square minus pi small r of x square, then dx. Right? So you can see I just applied Dix method for outer part, then subtract another Dix method for the inner part, that you can get the true solid. Right? So actually the Dix method, even though we say washer method, however, washer method indeed just apply Dix method twice. Right? So I can give you an example that, for example, if the region bounded by y is equal to x squared plus 1 and y is equal to minus x plus 3 is revolved about the x-axis. By using this concept, to generate the solid, please just find the volume of the solid. So again, you can see I will give you some curves. One is this one, the second one is this one, yellow one, green one, right? So try to draw it first. Draw the region first. So we can just follow this. We can draw it as this is x, this is y. So the first one is y is equal to x squared plus 1. So this is also the parabola. Okay, then another curve is its boundary. Y is equal to minus x plus 3. So we can see the curve region is this one. Through these two curves. Then the problem is also described that it just used x-axis as its rotation axis. So this is the rotation axis and rotated through this axis. And what's the volume, right? Okay, so this is the first step, and the second step is try to get its, because you know, if we want to use Washoe method, you need to have an outer one minus inner one, right? So outer one will be minus x plus 3. So according to this figure, this one in this region, this one, green one is higher than the yellow one. And the small r of s will be s squared plus 1, right? Then the third part, where is the two end? Where is the two end? One end is here, right? The other end should be here. So if you want to get these two ends, then you should put these two equations together, and these 2 points should be simultaneously satisfying these two equations. So the first one will be y is equal to minus x plus 3, and the second one is y is equal to x squared plus 1. Then using these two equations, you can get minus x plus 3 is equal to x squared plus 1, so that we can have x squared plus s, then minus 2. So that we can have s plus 2, then s minus 1 is equal to 0. So s would be minus 2 or 1, right? So that means these 2 points is, one is negative 2 here and one is here, right? So through this, we can know these 2 points. One is equal to negative 2, and the other one is s is equal to 1. These 2 points. Then finally, we just put all parameters together. The v will be integral from negative 2 to 1. Then we have outer part pi. Outer part is this one. Negative 3 plus 3, negative x plus 3 square, then minus pi s square plus 1 square, then dx. Right? Outer part subtract the inner part and sum them together. Finally, we can get the answer is this one. I also skip the detailed calculation and then leave that part for you to check by yourself. Okay, so let me quickly remind this idea for you that actually right now we already learned two methods. One is the disk method, the second one is washer method. Actually, these two methods are basically the same because for the washer method, they just simply apply this method twice. Okay? Then this is the section 1. This is section 1. And okay, so from this measure here to washer measure, I just simply move the rotation axis a little bit apart from this boundary from here. So you know you can use this one to apply it. But do you also think about that? If I just the rotation axis, if I give you also the same region, I also give you the same region. But the rotation, so you can see here, our idea is just like this. I just use this as a radius, right? So the height to here is perpendicularly to the rotation axis. So I use this to rotate. I use this to rotate to form a disk. For many disks, right? But if the rotation axis, I just move the rotation axis from x-axis to y-axis, how will it happen? The calculation may be a little bit different. But of course, you still can follow. So later I will show you an example. You can also use this method or washer method to get the result. And you also can use the shear method. I will introduce you later. By using the method to get the volume, but the answer will be the same. But different situation will use different methods. So right now we already know two methods. So right now we will move to the third one. That will be section 2. The volumes by cylindrial shear. Cylindrial shears. So think about it. Okay, if this is x, this is y, and this is the so-called the shear method. The third method we will learn in addition to the disk method, washer method, and finally we will learn the shear method. So the shear method is just like this. I still give you y is equal to blah 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 x, right? And I also give you the start point x is equal to a, and the end point is x equal to b. So if this time in the past, the rotation axis is here. If so, you can just simply use this method, right? Using this pi as the radius, and then rotate it by the x-axis. Then you can use each as usually not each as each one is this circle. This is what we just learned in the previous session. But this time I will not follow this way. This time the rotation axis will be moved here and then rotate, still using this region. So can you tell the difference in previous one and this one? In the previous one, this is the rotation axis. But this time we use this one. Okay? So if so, the idea will become different. So again, we will just use P as a partition point, from S is equal to A, S1, S2, then blah 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 to SK minus 1, SK, then blah 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 to Sn minus 1, then Sn is equal to B. Riemann sum again, right? So normally we just focus on the typical one here. So for example, if Sk minus 1 is here, Sk is here, so we just focus on here. I just purposely enlarge Sk, the width of the Sk minus 1 to Sk, because I just want to focus this typical one. So if I just use this one, then rotate it, you can just image that the result will be just like this one, that this is the rotation axis. We call it S is equal to L, right? Then this is x-axis. Then after we do that, you can just see for this small portion, here, this is Sk minus 1, this is Sk, right? So when we just rotate it, then if we rotate it, this part, so we can get this shear. So you can see this is just like a shear. Oh. This is just like a shear. Right? So this part, this small portion will contribute this value. So did you just find that this is just like a shear? 你们想想洋葱的壳一层一层 right? So for each one, from S0 to S1, we can do that. S1 to S2, we can do that. So this is the typical one. So we just illustrate it. So our focus we will just focus on how to get the volume. So we just cut it. We can make it become like this one. Almost. Actually, it's just a approximated result. Okay. Okay. If we just use a scissor to cut the share, then just implanted it become almost the same as a cube, right? So if so, okay, we need to know what is this, and also what is this, right? If we want to get the volume. Okay, for the first one, the simplest one will be, if here is delta sk, so here is delta sk, so you can see here is delta sk, right? About the width, right? About the height, how can we get the height? Did you remember when we just talk about the Riemann sum? We always randomly pick a point ck between sk minus 1 to sk. Then use this point to get its function value f of ck. Then we just use this high as its high, so this one will be f of ck. So no. Okay. And how about this one? So right now we have this. Let's say it's high. Maybe we'll just let it lower. This is almost use some point ck as f of ck. Then what is this part? This part will be, you can see, this is L. So we can just use it as we just use the length of the circle. So it will 2 pi times ck. We just randomly pick ck. Then minus L. Why? Because ck is here, the central point will be this axis. So the distance will be ck minus L. So we will use this radius. Then 2 pi r means the circle length, the length of the circle. You get it? Okay. So this small portion. So this small portion Vk will be 2 pi ck minus L times f of ck times delta sk. So if you can have this small portion, you can just apply the same idea to each small portion. So that we can get V is almost the same as sigma k is from 1 to n Vk. So that means is equal to sigma k is 1 to n 2 pi ck minus L times f of ck delta sk. So again, as non p is approaching 0, so that means n is approaching positive infinity. So V is almost equal to limit n is approaching positive infinity, or we say non p is approaching 0 for this summation. so that actually the result is equal to integral from a to b, then 2 pi. As you know that if we can have a non-p is equal to 0, that means we can have an infinite number of points, partition points. So almost each ck will become every x, right? So you can see the result will be 2 pi times here will be x minus L, then f of x times delta x. So you can have a mapping. Here is here, right? And f of ck will be converted to f of x. Then the last one, delta sk, will become this one. So this is the final formula. And we also can formulate as v is equal to integral from a to b, 2 pi. The first part is the shear radius. What is shear radius? Shear radius is from this point to the central point to the rotation axis point. Then shear height, then dx. Okay, so finally, what you need to memorize is this part. Okay, so let's just take some break and then come back to the classroom later. Here is an example by using the shear method to calculate the volume. If I give you a sy and its function is just y is equal to 3x minus x squared. So the function the shape we will just do like this one. And we just use this shape in the first quadrant to rotate. But again, if the rotation axis, x-axis, or any axis parallel to x-axis, you can just use the disk method or washer method. For example, if the rotation axis here, if here, you can just use disk method. If the rotation axis is here, this is disk method, this is the washer method, right? Using the outer one, subtract the inner one. But right now, they just request us to do is the rotation axis here, axis minus 1. And this one, we will use the shear method. Okay, so if we just rotate by this, you can just image that finally the shape will just look like this one. Maybe not that precise, but almost. Almost the same. Right? If you just rotate it through this, you can see the shape. Okay, so right now we try to use the shear method to calculate it. So I also put the formula here for your reference. V should be integrated from AB to pi. Then shear radius. The so-called radius is shear radius is each x point to the rotation axis. Try to use the length as the radius. Then also shear height. Shear height means you just regard each x as a pickup point, a peak point. Then use the peak point to calculate its height. Then dx. So this is the formula. So just remember in your mind. Okay. So based on this, first we need to figure out what is the shear radius. The shear radius is just use each x, right? Each x, and try to get its length between the point and the rotation axis. So we need to get this one. So this is the shear radius. It will be x minus L, right? L is minus 1. This is the shear radius. Then we also need to have a shear height. It will be, we just simply use its height. This is its height, right? Because we just use x as a pick point and use this one as an input for this function, so we can get the height here is 3x minus x squared. So the result will be 3x minus x squared. And the second part is we need to have to know what's the two endpoint, right? What's the two endpoint? So if you want to get the two endpoint, you need to use y is equal to 3x minus x squared, and also y is equal to 0. Then you can get s is either 0. Oh, sorry, maybe I just made some mistake. Suppose this is 0. So the x-axis should be eraser. Okay. Actually, so actually the x-axis should be here. Should be here. Sorry, this is my mistake. Okay, this is, so s is either 0 or s is equal to 3. So these 2 points is s should be 0 or s should be 3. Then finally we just put them together. So v will be integral from 0 to 3 shear radius. So shear radius here will be here. Shear radius times shear height here, then here, then dx. So through some calculation, you can get the result will be this one. So this is the shear tensor. So can we just use this? Still the same question. Can we just use this method or washer method? Actually, we can do that. Okay, So we can see this is solution 1. The solution 2 is, I will quickly go through that, but we will not spend too much time. So this is still y is equal to 3x minus x squared. Then the rotation axis is s is equal to minus 1. So we still use this, and the rotation axis is here. But here we just use shear method. So can we just use this method? Can we just use the one-shot method? Yes, we can do that. We can do that. Just think about it. I just divide it into 2 parts. One is this part. One is this part. So you can see if I use the yellow part to rotate minus the inner part. So, but that takes some time to do that. So I will quickly to solve this for you. So for example, in the beginning, y is equal to minus x squared plus 3x. Then make it perfect squared. So it will be like this one. Right? So through adding subtract one item and adding the same item, then we can get this one. But this can make us to have negative x minus 3 over 2 square, so that we can have y minus 9 over 4 is equal to negative this one, right? So x negative 3 over 2 is equal to positive or negative square root of 9 over 4 subtract 1. So it's just simply just move some item to right, move some item to right, you can get this one. So if we can have this, we have 2 parts. The first part is bigger r of y is equal to 3 over 2 plus square root of 9 over 4 square root of 9 over 4 minus y. Then the small r of y is equal to this one. So please just have a mapping. This part, yellow part is for this one. Inner part is for this one. So you can see with this we can use the one-shot method to calculate v is equal to integral from where? From here is y is equal to 0. The point here is y is equal to 0 to the very top point. It will be 9 over 4. Okay, so that will be from 0 to 9 over 4. And using outer pi r of y squared minus pi over r of y squared, then dy. You know this part, just solve by myself. You cannot find this part in the textbook. I just want to show you. for the same question, you can choose different solution to solve the same problem. Okay, then of course maybe the calculation a little bit complicated, but you can just simply use the pi by using this one. Then you can have, we just simply move the y, the pi, because we have common item pi. Then we can have maybe some mistake here. I forgot to do something. Our y should be still have, because the distance here we need to calculate yellow part minus 1. Why? Because we will use the distance from yellow curve to this rotation axis. So we need to minus -1. Okay? So I forgot to do this. So remember to add this one. Because the axis is not just exactly y is equal to 0. It is s is equal to 0. It is s is equal to -1. So it will be this one. So that it will be 5/2 plus minus 5/2 negative square, then dy. So it will be pi square root of 0 to 9/4. Then we will have 4 times this item you can regard this as a plus b square minus a minus b square. So finally we have 4ab. Okay, then dy. So the result will be here 10 pi integral from 0 to 9/4 square root of this one. And also do some calculation, you can get the result is like this one. You can just simply use the subtract some rule, and you can get the result, and then finally it's still this one. So I just hope you can just have some comparison here and here. This one just use a shear method, so you can see it's much simpler, right? 可乘法比较简单，对不对？可乘法只要利用一次，对不对？但是我要告诉大家的是，同样的问题呢，我也可以用比较麻烦的 partial method 来解，就外层减掉内层，外层的 disk 减掉内层的 disk。那这计算有点复杂了哈，这个要慢慢回去体会。只要记住，外层是这个黄色的，要去减掉粉红色的；内层呢是绿色，要减掉红色的。利用这两个的半径带出两个圆去相减，你一样可以得到用这个 B 区间去旋转于这个 s 等于-1的旋转体积。那反观这个呢，是用可乘法，可乘法是拿这里到这里是当做 radius 的半径，这边是 radius 的高度，去一层一层的去乘出来。那一层一层出来，它会多这2拍。这刚刚有讲出这个原理，为什么是在这里？这里真的很复杂。如果是第一次听或者第一次体会，很复杂，要回去慢慢细细体会啊。但是呢，等一下我会告诉大家一个原则，你可以利用那个原则来决定你到底用 shear method 和 disk method。 但是再次强调，不管你用 shear method、Dix method， 它都可以。如果你解法正确其实是真金不怕火炼的。虽然你可以用很简单的 shear method 去算出来，你可以用我这么复杂的 washer method 去解出来但是这个看起来是要花比刚刚的计算多一点时间的，而且也很有可能中间不小心你可能就会算错所以我接下来就要告诉大家怎么样去判断了所以这边比较难一点点，我们不要讲太快Okay, so I will tell you the step about of the shear method. The first part is still draw the region, and this is very important. Sketch a line segment across it. It here means the region. Okay, across the region. And how to get the line segment? It should be parallel to the axis of revolution. That means the line segment should parallel to the axis of revolution. That's how I will show you. Okay. Then the second part is find the limit of the integration. And the third one is integrate the products 2 pi times shear radius and shear height. Okay, so I give you an example that how to distinguish. If the first step is here, I give you the simple example that this is y is equal to square root of x. This is x, this is y. Then from 0 to 4, this is the plane region, right? If your rotation axis is here, then I use this to rotate by following the rotation axis as y-axis. Then you can see here, sketch a line segment parallel. This part is important. Please just pay attention to here. A line segment across it. 用一个线段去穿越这个 region， 但是这个线段要怎么样？平行于旋转轴。So the line segment will just lie here. This is the line segment. Did you notice this line segment is parallel to the rotation axis or axis of rotation, right? So you can see this is the region. I just draw a line segment. Line segment should be parallel to the axis of rotation. Not this way. This segment is perpendicular to the axis of rotation. So it should be this way. If this way, it will follow the disk method or washer method. But this time we use shear method. So the line segment should be parallel to the axis of rotation. Okay, so in this case, we need to know the shear height. So the shear height, shear radius first. Shear radius. What is shear radius? Shear radius is for each x, we need to calculate its distance between this point to the rotation axis. So it will be x minus 0. Right? Each point, we need to calculate the distance to the axis of the rotation. So it should be x minus 0. But of course, in this case, the rotation axis is just exactly equal to s equal to 0. So that's why 0. But if s rotation axis is here, s is minus 1, so here will be minus 1. Okay? So this case is very special because the rotation axis is y-axis. So no wonder here is 0. But if it's not, it will be possibly another number, not 0. Okay? And then shear height. Shear height means for each point, what's the height? So this is the shear height. Shear height. This is shear radius. Okay? So shear height will be square root of x. This is the first step. The second step is try to get the limits of integration. In this case, it's simple. It will be 0 to 4. Then we just put them together, we can get v is equal to this one. 2 pi shear radius shear height dx. Then the answer is easy. It will be this one. So again, I just skip the detailed calculation. Okay, so the type 1. Another one is if the shear radius here, the shape is still this one, and still 0 to 4. But this time, if the rotation axis is here, this is rotation axis. So in this case, 2 ways. The first way we already learned in this method or washer method. This method, you can see, it's simple, right? We just use this as a radius. Then rotate, then we can get this. Rotate, we can get this. Rotate, we can get this. So we can simply use this method. It's more than enough. But this case also can be solved by using shear method. So if we want to do it by shear method, you can see according to the algorithm, according to the process, the first thing is draw the region and sketch a line segment which is parallel to the axis of revolution. So already have the segment, already know the axis of revolution. Then we need to draw a line segment, which you can see, which must be parallel to the axis of revolution, right? So this is a line segment. If you want to use shear method, remember the line segment should be parallel to the axis of revolution. But if your line segment is perpendicular to your axis of revolution, it will be this for Washoe method. So it's easy to distinguish which method you want to use. If you want to use this one, Washoe method, this method, just perpendicular to the rotating axis. If you want to use Washoe method, remember the 9 segment should be parallel to the axis of the revolution. Okay, with this, we still need to we need to rewrite this one as S is equal to Y squared, because this time our viewpoint will be from Y's angle, not X angle. Y's angle. Okay, so we need to rewrite the function. And here will become S is equal to Y squared. And here is S equal to 4. So the shear radius is still at some certain point of Y, right? So this is the shear radius. So let me just write down shear radius is still Y from Y viewpoint. As for its shear height, it will be 4 minus Y squared. That means here is its shear height. The shear height will be here. You need to calculate its distance. So the shear height will be 4 minus Y squared. Okay, so right now we already shear radius, shear height, and we also know the integration, the limits of integration will from 0 to 2, because here the endpoint is 2. Okay, so then we just put them together. V is equal to integral 0 to 2 pi shear radius times shear height. Then dy. So the result is still 8 pi. So different. Did you remember we also solved this as 8 pi by using this method? I try to find a no. Okay. Let me try to find the pacifier. Okay, let me find a file for you. Calculus. Okay, as I remember here. Oh no. Maybe this time. Oh, not yet. Maybe here. Oh, it's so weird. Oh, this time. Oh, okay. Okay. Okay, here. Did you remember this case? This case. just this Monday. Here, you can see this y is equal to square root of x, right? This is the rotation axis. This is start point, this is end point. And we just use this shape to rotate this plane region by following the s-axis of revolution as s-axis. So did you notice that next time we just use this method? Did you notice here, perpendicular to the axis of revolution? So we just use this height as the radius, pi r squared, and start point and end point, and integrate this part. This method. This method. The same problem to get the volume, right? Today, we just learned a new method. Today, we just learned a new method. Here. Right? Same problem. But this time, we just try to use shear method. So shear method, the line segment should be parallel to the axis of revolution. Shear radius very high, but it becomes a little bit multiplicated, but the answer is still the same. But we just use different method. So that means you can either use shear method. See, in this case, shear method is easier, but you still can insist using washer method, but become more complicated. In this case, you can use this method, washer method, it's easier. But if you insist shear method, it will become a little bit complicated. 我今天要讲的说这个很重要哈，这个很重要。这几个办法哈，会很混，有时候会很混淆。但是有一个原则，你去看看你的 line segment， 如果你的 line segment 跟你的旋转轴是平行的，你就是走什么 method？ shear method。如果你的 line segment 跟你的旋转轴是垂直的，就是 disc 或者是 washer。你只要记住这个原则，你就不会搞混了，了解吗？而且这两个是可以混用的。但是呢，我刚刚提到这个例子，你的 line segment 平行于旋转轴，用 shear method 就是找出那 shear radius、shear height， 然后把它斗起来。你看基本式子很简单。如果你坚持要用所谓的 washer method 或 disc method， 你看以这个例子垂直嘛哈，所以你要 line segment 应该在这个方向，你就会分成外环跟内环，所以你的式子兜起来就是会这个比较复杂，算起来比较复杂，答案还是一样的。所以这个例子是什么？用 shear method 比较简单，同样的问题用 disc 或 washer method 来解比较复杂，答案还是一样的。这个例子呢是原先用 disc method 来解比较简单，反而用 shear method 比较复杂，因为你要去算这中间的距离。但是他们答案都是一样的。这个就是刚刚我上一次上课投影片给大家看的。所以你自己可以去判断一下。所以在这种题目的问题上面呢，你就要先把图画出来，再去稍微剖析一下，它到底我是跟它垂直用 disc 或 washer method 比较好呢，还是我跟那个旋转轴是平行的，用这个所谓的所以 shear method 会比较好呢？大家要做一个判断哈。Okay, so it's almost done for session 2. So I just roll down here. Okay, so we still have several minutes. So because because our target is 7 in chapter 7 and section 3 or section 4. So our target is, this is our endpoint for the final exams. So I need to seize anytime. So maybe I just quickly give you the idea, but no worry. Next week I will give you some review. So we also think about how can we just use the integral to calculate the arc length. So arc length is just like here. Arc length means if I give it y is equal to f of x, then still I give you have s is equal to a to s is equal to b. Can you try to calculate the length? This time we are talking about the length instead of the volume, instead of the surface. So if so, again, I will give you a partition. P is equal to S is 0 is equal to A, S1, S2, but here Sn minus 1, Sn is equal to B. So that means I also pick several points randomly, and especially we have Sk minus 1 and Sk. So you already know the idea, right? Raymond's out. Still Raymond's out. Okay? So if so, for example, if Sk here will be Pk, P of Sk minus 1. And another point is P of Sk. These 2 points. And then if I want to know the whole length, if I can know this portion, then we can just sum them together. So the idea is we just enlarge this part to, like, here is, this should be f of. So then we can enlarge these 2 points, become, this is f of Sk minus 1, Fsk, and this is Sk minus 1, right? Then we try to calculate it, but the true length is this one. I just enlarge this portion, this small portion to this one. So you can see, ideally, it should be the white one. But since white one is not easy, so we just use the yellow one to replace this one. So if here is delta yk, and this is delta sk, and here this is sk minus 1, here is sk. So this length is delta sk, right? So ideally, the LK here will be square root of delta sk square plus delta yk square. I think we cannot finish this part because we still have several parts need to introduce to you. Okay, maybe let's just stop here because we cannot finish the rest part within 5 minutes. So let's just stop here and see you next week.你还记得吗？